Alrighty, so making sure my headset's on. Sorry. Okay. So for this lesson, we're going to be graphing linear equations. This is the brand new unit. A solution of an equation in two variables is an ordered pair. And ordered pairs are just points on a grid. Is an ordered pair. Remember, points on a grid are always written in parentheses with x comma y. That produces a true statement for the values of x and y when they are substituted into the equation. So the equation is this particular thing right here. Tell whether the ordered pair is a solution to this particular equation. Well, every ordered pair gives you an x value and a y value. All that you need to do is plug in the x value and the y value into the equation, do the math to figure out if what comes out is what you're supposed to get. So 2x minus y, does it equal 5? 2 times 3 is 6. 6 minus 2 equal to 5, but 4 does not equal 5, so this ordered pair is not a solution. The answer would be no. Same equation, different values. Again, x and y. So 2x minus y, it's a negative 9, it's minus a negative. Does that equal 5? Well, 2 times negative 2 is negative 4. This becomes plus 9. Does it equal 5? Well, 5 does in fact equal 5, so that ordered pair is a solution. Okay. The graph of an equation in two variables is a set of all points in a coordinate plane that represents all the solutions. So when you graph an equation in two variables, you're just basically graphing some sort of line. And any point on that line would actually be a solution to any equation that we gave you that was for that particular line. So a linear equation is an equation whose graph is a line. The standard form of a linear equation is going to be ax plus by equal to c, where a, b, and c are both real numbers, but a and b cannot both be 0 at the same time. You need to always have one variable, either x or y, to have a line. You most often have two variables, x and y, but you can't have no variables. It wouldn't make sense. Variables, again, meaning x and y. The slope-intercept of a linear equation is this equation, y equals mx plus b. M stands for your slope, which happens to be your rate of change, and b stands for your y-intercept, which is the place on the y-axis that your line intersects or crosses over. So when you need to graph a linear equation, the idea is you're going to make sure that your equation's in slope-intercept form. You're going to make a table using, well, you're going to make a table of values, and they're going to give you the domain, the x values, -2, -1, 0, 1, 2, as your x's. You're going to plug in those x's into those equations and find out your y's. And then once you have all those ordered pairs, you plot those ordered pairs, and then you draw your line, and then you can't forget the arrows because lines go on forever. So what we would need to do for this particular equation is subtract 2x on both sides. And the equation then becomes y equals -2x minus 4. And then everywhere you have an x, you're going to plug in all of those x values. So -2x minus 4, -2x minus 4, -2x minus 4. I think you get the idea. You're going to plug in -2 for the first one, do the math, and you're going to get 4 minus 4, which is 0. And then the next x value gets plugged into the x, and you do the math, and you get 2 take away 4, which is -2. And then the next x value gets plugged in for the x, 0. And then you do the math, and you get 0 minus 4 equals -4. And you keep doing that all the way down. So when 1 gets plugged in, -6 comes out. When 2 gets plugged in, -8 comes out. Once you have all your points, then you plot them. X's mean you go left and right, y means you go up and down. So -2, 0, that's the first one. -1, -2 is there, 0, -4 is here, 1, -6 is here, 2, -8 goes off the graph, not a big deal, I'm not even going to worry about it. I have enough points. I'm going to connect those points to the line, I put arrows on the end. Next one. Let's get this into y equals mx plus b. So I'm going to just come down here. 2x equals 2y plus 8. And I'm going to subtract 8 from both sides. and I'm going to get 2x minus 8 equals 2y. I'm going to divide everything by 2, and I'm going to get 1x minus 4 equals y. But I think that looks better with y equals 1x minus 4. So now I'm going to plug in all of these x values into the x. So this first one is going to be y equals 1x minus 4, 1x minus 4, 1x minus 4. And again, you're plugging in -2. You're doing the math. -2 minus 4 is -6. You're plugging in -1. 1 times -1 is -1. Minus 4 is -5. Now you're plugging in 0. 1 times 0 minus 4. And you're doing that all the way down. Once you get your ordered pairs, you plot them. -2, -6. -1, -5. 0, -4. 1, -3. 2, -2. And then there's my line, arrows on either end. Sometimes you don't have lines that have both the y and the x. You might have lines that are in one variable. Okay, and that kind of takes us back to here, where in the beginning, the equation is going to be the standard form ax plus by equals c, where a and b cannot both be 0. It means one of those variables cannot be eliminated. And that's kind of what happens on this stuff. So horizontal lines and vertical lines. Horizontal lines, you know, are lines that look like this. Vertical lines are lines that look like this. I tend to give these lines special names. I call horizontal lines lazy lines, because when you're lazy, what you like to do is lie down. I call x lines excited lines, because if you're excited and you're at a sporting event, you're probably going to be standing out of your seat. Well, what's kind of clever, hopefully, is that y lines, which are lazy lines, are horizontal lines. So when I see this equation y equals -3, it's a y line. And y lines are lazy. So I'm going to find -3 on my y-axis, and I'm going to draw a lazy line, a horizontal line through it. What happens over here for x lines? Well, x lines, I'll go this way, x lines are excited lines, which happen to be vertical lines. And what I'm going to do is I'm going to find on my x-axis +2, and through +2, I'm going to draw my vertical line, my excited line. Okay? What's interesting to know is that, well, not really interesting, but you can probably tell, if you have a y equals line, y equals lines, they are always horizontal. And if you take a look at where this line is parallel to, this lazy line is parallel to the x-axis. These lines will never intersect. That's a symbol for parallel. So y lines are horizontal and parallel to the x-axis, where x lines are always going to be vertical and parallel to the y-axis. Let me come back down here for 1 second. So x lines, this x line right here, this vertical line is parallel to the y-axis. Okay, that's it. So you should be able to do your homework from here.